Okay, what I'd like to do now is go through question number 14 from the study guide for Math 136. This is from Unit 4, and this is the spring 2012 edition of it in case it's changed. So, number 14 is about solving a series of logarithmic and exponential equations, and letter A says to solve for x, 7 to the x minus 1 is equal to 9. This is written as an exponential equation. Notice we don't have like bases between the 7 and 9, nor can we convert one into the other. So we're going to have to solve this using logarithms. Well, what we simply have to do here is translate this exponential statement into the equivalent logarithmic statement. Well, this gives me that the power, x minus 1, is equal to the logarithm base 7 of the resultant 9. Well, notice we're well on our way to isolating x, and we get x is equal to then 1 plus the log base 7 of 9, and this is an exact answer for our question. Letter B, number 14b, is the logarithmic equation, the natural log of x cubed minus 2 times the natural log of x is equal to 8. Running through to solve this, what we're going to do is we'd like to combine these two logarithms into a single logarithmic term on the left-hand side. To do so, I'm going to go ahead and bring the power of 2, or excuse me, the factor of 2 outside the logarithm, inside this second logarithm as an exponent. That gives me the natural log of x squared. Once we've written the left-hand side as a difference of logarithms, remember that when we have subtraction outside the logarithms, that is a difference of logarithms, we can rewrite that as division within the logarithms. So I can rewrite this as the natural log of x cubed divided by x squared. And that is again equal to 8. Now I've got a simplified logarithmic statement. The natural log of something is equal to its result. And I'm now going to convert this into, well, let's go ahead and take a line here and simplify this to the natural log of x is equal to 8. And now we can simply translate this to x is equal to e to the 8. Right? My base here is implied e. 8 is my exponent, or 8 is my power, and x is the result. So there we've simplified it. For letter C, we have, again, this is similar to the last problem, the natural log of x minus 1 minus 3 times the natural log of 2 is equal to 6. Rewriting this in the same strategy as before, we get the natural log of x minus 1 minus the natural log of 2 to the third power is equal to 6. So again, what did I do here? I brought the factor of 3 inside the logarithm as an exponent. Simplifying this then gives me the natural log of x minus 1, natural log of x minus 1, minus the natural log of 8 is equal to 6. Now we have again a difference of logarithms, rewriting that as division within the logarithm. We've got the natural log of x minus 1 all divided by 8 equal to 6. Now we've got again a single logarithmic expression, a single logarithmic statement that can be rewritten as an exponential statement. So this simplifies then to x minus 1 divided by 8 is equal to e to the 6th power. So again, let's just recopy what we had. We had x minus 1 divided by 8 is equal to e to the 6th power. Solving for x, we've got an equation with fractions in it, multiplying both sides by the common denominator of 8 gives me x minus 1 is equal to 8 times e to the x, or x is equal to 1 plus 8 e to the x, or e to the sixth. Excuse me, I think I may have said that earlier. X is equal to 1 plus 8 e to the sixth power. And there we have our answer.